Hello everyone, today we are going to learn about inverses in pre-calculus. So you should recognize the word inverses from Algebra 2 right here. We learned a couple things about inverses. First of all, the word inverse means opposite. So you're literally going to take your x and your y values and switch them. Whether it's numbers or letters, whatever you are given, you're just going to take your x and your y and you're going to switch them. Okay, the second bullet point we have right here, the graph of the inverse of f is the reflection of f across y equals x. This is just like a fun fact of the day bullet point. This isn't really super necessary for our class here. However, if you had a graph and you wanted to find the inverse, you could reflect it across the line y equals x. This is really important for us right here. So two functions, f and g, are inverses of each other if fog of x is equal to x and goth of x is equal to x. Now, if you remember last time, we said fog and goth are not things. So we're going to rewrite that as f of g of x. And when you solve that, because you know those are formulas, you're going to substitute, you're going to solve. When you solve that, your answer should be literally just an x. The reason is because they are inverses, they are opposite, so everything should cancel out, and you should be left with just an x left over. The same exact thing would happen if you did it the opposite way, or the other way. Okay, f of g of f of x would also be equal to x. So if you ever see prove, yes, there are proofs coming in this, that prove that they are inverses, you're going to have to perform both of these compositions. So you're going to have to do f of g of x and g of f of x, and both of your answers should be x. And our last bullet point from Algebra 2, the horizontal line test. You're like, wait a minute, Ms. Schweitzer, it's supposed to be vertical line test. Well, the horizontal line test is to tell if the inverse will be a function. So if I drew an xy axis in my favorite graph ever, a parabola, does that pass the vertical line test? Yes, that means that f of x is a function. Cool. But if I want to know about the inverse, remember that little -1 from trig? That's the inverse. If I want to know if the inverse is a function, I have to do the horizontal line test. Oh my God, that hits the graph twice. That's not a function, which means the inverse of that graph will not be a function. The vertical line test is for the original function f of x. The horizontal line test is for the inverse of the function, or the f with the -1. Okay, so here, this is what's new for pre-calculus. If something is 1-to-1, it means for every x value, or sorry, for every y value, there is exactly one x value. Then the inverse is also a function. So if you want to decide if something is 1-to-1, it must pass both the vertical line test and the horizontal line test. So in example A, the vertical line test, it passes, which means f of x is a function. The horizontal line test, it fails. So f inverse is not a function. If you don't pass both, you are not 1-to-1. So this function is not 1-to-1. What about for part B? It passes the vertical line test. So for f of x, that's yes. It also passes the horizontal line test. So for the inverse, that's also yes, a function. And because it passes both, we would write that that is yes, 1-to-1. Same thing for part C, I think. It passes vertical, it passes horizontal. You can write yes, that function is 1-to-1. And D passes vertical, fails horizontal. No, that is not 1-to-1. So that's what's new here. Okay, number 1 is way too easy, so we're going to completely skip that problem. And we're going to move up into the pre-calculus one. So for number 2, we need to first find the domain and the range of our original f of x function. What does that graph look like? Yeah, you're right, it's a straight line. So our domain is negative infinity to positive infinity. And so is our range. It really just looks like this. Okay, now, for the inverse of that function, you're literally going to switch your x and your y. But I don't see a y over here in my purple function. Oh yeah, f of x is y. So I'm going to switch my x and my y all the way over on the right. I'm going to leave all this space. And I'm going to write x equals 2y minus 3. We're going to switch them. Then you're going to get the y alone. So I'm going to add 3 to both sides. X plus 3 equals 2y. I want y alone, so I'm going to divide 2, divide 2. So since I have y alone, this is my inverse function. So I can copy that answer up here by f negative 1, or the inverse of f, x plus 3 over 2. Now, what is the domain of the inverse function? We know there are two really bad things in that: fractions and square roots. We have a fraction, and we know the denominator of the fraction is not allowed to be 0. Guys, 2 isn't 0. 2 will never be 0. So here, because there's no variable on the bottom, there are no restrictions. That fraction can be whatever it wants to be. So since it has no restrictions, my domain is negative infinity to positive infinity, and then I have to figure out my range. I don't really know how to do that, but I can use this original graph to help me. Okay, when you find the inverse, don't you switch your x and your y? Okay, so now my range is my domain over here because I switched my x and my y. My domain is now my range. They're going to just switch. So since I know my domain is negative infinity to positive infinity, you're going to copy that down here into your range. It's also going to be negative infinity to positive infinity. Okay, so your x and y switch, so your domain and range switched as well. Let's give that another try. Okay, actually, for number 3, we're going to go ahead and cross all of that off. And for number 4, ooh, I like this one. Let's find our domain and range first. Okay, here we go. Domain. We know there's a fraction. We don't care about the top, but we know the bottom is not allowed to be 0. So we know x is not allowed to be 5. We write our domain as negative infinity to 5, union 5 to infinity. Okay, I know that when my inverse, it's going to be switched, so that's actually going to be my range. I don't really know how to find the range without picturing this graph for f of x here. But I don't know what that looks like. Well, I remember that back from Unit 1B, where we did rational functions with horizontal asymptotes and vertical asymptotes. I could figure out the range if I wanted to. But I know that we have a lot of things going on and we probably forgot. So why don't we just find the domain of our inverse and then copy it over to our range? That's more fresh in our range. First thing we're going to have to do is actually find the inverse. So that means we're going to have to physically switch our x and our y. Right? This is going to be y, but I'm going to switch it. And I'm going to write x equals. Now, here's the problem. There are 2 x's, or there were 2 x's. Now there are going to be 2 y's. So, because you're switching x and y, everywhere you had an x, it now has to turn into a y. Okay, we're going to solve this for y. This is where things are going to get so exciting. All of your algebra rules come back to haunt you. So, x is over 1, and let's cross multiply. Let me move this up so I have some more space. Okay, cross multiply. When you cross multiply, you have to distribute. So it's going to be xy minus 5x is equal to y. Now, I need to solve for y. I need the y alone. So I need to collect all of the y's on the same exact side. So let's bring xy is okay. Let's bring that down. Who else has a y? Oh, yeah, this guy. So let's subtract him over to the other side. And I don't want that 5x over there. I only want y people over there. So I'm going to add the 5x to the other side, and I'm going to end up with this function right here. Okay, I have two y's there, and I need to get the y alone. So I'm going to factor it out. Okay, if I factor out a y, aren't I going to have a y almost alone? So anytime you have two pieces with y, you want to factor it out. So when you factor that out, you have x minus, don't forget that 1, left over, and that's equal to 5x. Okay, remember, this is multiplication. How do you cancel multiplication? Well, you divide, and you want the y alone. So you're going to divide by x minus 1 on both sides. That's going to cancel. Oh my god, your y is finally alone. So really, your inverse is y equals hot mess. So 5x over x minus 1. Okay, but we don't write the y, we write f negative 1. So the inverse of that function is 5x over x minus 1. I'm going to rewind and I'm going to state the steps again. So step 1 was cross multiply. Step 2 was find the answer to your cross multiply. Step 3 was bring all the y's together on the same side. And then step 4 was factor out a y. Step 5 was divide by whatever is not y. And we're going to do that again, but I would put a giant star on that question. Now, the only thing we have left to do is find our domain so that we can copy it down for our range over here. You know the bottom of the fraction cannot be 0, so you know your domain here is negative infinity to 1 and 1 to infinity. Since that was your domain for your inverse, it's actually your range for your original. So negative infinity to 1, 1 to infinity copies over. That was a lot. And so we're going to do all of that again, except I have to tell you something. The domain and the range part are not important for your test. So we're actually going to cross off this section and use all of this space to find the inverse of that function. Okay, let's just focus on that part first. So what we're going to do is we're going to switch our x and our y. That is step 1. Okay, so I'm going to write x equals, and every time I see an x, I now have to write a y. Now, I see fractions, I can cross multiply. So let's cross multiply. I get 9xy equals 1 times anything that stays. I need the y alone, so bring all the y's together on the same side. Then I really need to get that y out of there. I need to factor him out. Okay, he's actually with both of those people, so let's kick him out. Let's factor him outside. So we have a y on the outside, and we have 9x minus 3 left over. We want y alone. So don't factor out a 3 with it, just factor out the y. Then, this is multiplication. To cancel multiply, you have to divide it. So you divide by 9x minus 3 on both sides. I want that gone so the y can be alone. And my inverse is y equals 5 over 9x minus 3. I don't need the y, I need my inverse notation. So 5 over 9x minus 3. If you wanted to, you could totally find the domain and the range of that, but you don't have to. So let's try all of that again. For number 6, cross off domain and range. We're not going to do that. We're going to focus on just finding the inverse. Okay, over here, we're going to switch our x and our y. So let me erase this so we have some clear space. And so I'm going to put x first, and then everywhere I see an x, I'm going to put a y. Step 1 was cross multiply. Make sure you distribute that x to both. So it's going to be 3xy plus 7x is equal to 1 times anybody will remain the same. Okay, I want all the y's on the same side, so 3xy has a y, and 2y is going to change and be negative. I copied down my equal sign because I don't want that 7x over there. I want him on the other side. He doesn't have a y, so move him to the other side and make him negative. Then when all your y's are on the same side, you're going to factor it out so that it can be alone. And this is multiplication, so cancel multiply, we divide by all of that hot mess. And you have done it. You have found your answer. So I don't need to copy the y, I just need to copy the inverse of the function, which is this. So negative 7x minus 5 over 3x minus 2 is your final answer for your inverse. So if it asks you find the inverse, moral of the story, switch your x and y. If those three problems confused you, please go back and re-watch this all again. And then there are a couple problems that are similar on homework number 5. I would suggest you try by yourself and check your answers on Google Classroom. Now, this is the abridged version of the lesson, so the things that are not important get to go. So slash that out, we're not doing that. And we are going to move ahead on to this page, your favorite thing ever, proofs. So we need to prove, like I said at the beginning, prove that these things are inverse. There's two things you need to do. You need to prove that f of g of x is equal to just x, because everything should cancel if they are inverses. But that's not enough. You also have to prove that g of f of x is equal to x. Everything will cancel out. So here we go. Split your space anytime you see prove into two separate spots. First, you're going to do f of g of x. So remember, this is where I told you to copy down your outside function without his x at all. So copy down the f function without x, a giant parenthesis. So 4 blank minus 5. What are we substituting inside? Oh yeah, we're substituting g of x inside. So I'm going to substitute x plus 5 over 4. Guys, my goal is to get x as my answer. So right now, you should notice that a 4 on the top and 4 on the bottom will cancel. I know you're thinking it. Yes, you must show every single step. This is a proof. I want you to convince me that you are an actual mathematician. So your 4's will cancel. You'll have x plus 5 minus 5 left over. Plus 5 and minus 5 will cancel. And oh my God, look at that. Because they're inverses, everything canceled, everything was opposite, so we are left with just an x. That's good, but it's not going to be. We also need to find g of f of x. So this time we're going to copy down the g function, which is this red function here, I'm going to erase, without the x. So parenthesis x is gone, plus 5 over 4. I'm going to substitute f of x on the inside. F of x is 4x minus 5. And I don't really need those parentheses because there's nothing to distribute. So the first thing I'm going to do is cancel the minus 5 and the plus 5. I'll be left with 4x over 4. 4's will cancel, and you have just an x. So did you get x for both? Yes, that means yes, these are inverses. So you did all of that work just to write yes at the top. No, just kidding. You proved to me that you really know how to solve these problems. And you know that an inverse means everything should cancel. Okay, similar things are going to happen for number 2. I'm going to skip number 2 because it's way too easy. Okay, but if you want to check your answer for number 2, the answer key is on Google Classroom. You can try it and check it. I'm going to do number 3. This is your challenge question, and it's on your test. So the big stuff. Okay, so anytime you see proof, split your problem up. You want to do f of g of x and g of x. Okay, f of g of x. We're going to copy down this function without its x's. So you can see already this is going to get pretty dicey. I'm going to substitute g of x in here, 9 over 5 minus x, 9 over 5 minus x. Substitute that in. Okay, let me help you with your algebra skills. The first thing you're going to do is multiply the 5. You're going to distribute it through. Really, it's 5 over 1, so 5 times 9 is 45. 1 times all of that, and that's on the bottom, is still 5 minus x. Then you have to copy down this minus 9. I'm going to put it over 1 because I have a feeling I'm going to have to find denominator things. Okay, and that's all over 9 over 5 minus x. Everyone's always like, this right, sir, I can cancel things. No, you can't. You need to make a common denominator first. So I'm going to do plus, negative, and I'm going to do my dead sign seconds. So 45 times 1 is 45. Negative 9 times all of that, imagine there are parentheses there. Negative 9 times 5 is negative 45. Ooh, this is looking good. Negative 9 times negative x is positive 9x, and all of that is over, don't forget to smile, 5 minus x. Okay, again, that was just the top. We have that blue bottom on right now. So 5 minus x. 9 over 5 minus x is on the bottom. Yeah, I need so much space for this. One thing I do notice is starting to look good is 45 minus 45. So really, when we copy down that black fraction on the top, I have 9x over 5 minus x. Then I'm actually just going to keep change flip right now. I'm going to change that divide to multiply and flip that blue fraction over. Okay, if you want parentheses here to make you feel better, you can. And almost cancel. Oh my God, guess what? That leaves you with 9x over 9, which cancels and just gives you x left over. Hey, process. Breathe. You are okay. You are a smart human. If you didn't understand it, go back and watch it again. For g of f of x, we're going to copy the blue function on the outside without the x at all. Then we're going to substitute the red function on the inside. So 5x minus 9 all over x. First thing I'm going to do is distribute this negative through on the top. Okay, so I'm going to have 9 over 5. I'm going to put a plus sign. I know that seems weird, but trust me, it's going to help you with your common denominators later. For that red fraction, I'm going to distribute that negative, so it's going to be negative 5x plus 9 all over x. Yeah, you should be thinking it right now. Dead silence a lot. 5 times x, that's all over here, is 5x. 1 times everybody is just everybody, so minus 5x plus 9, and don't forget to smile, all over x. Now, the problem here is, what was on the top? Oh yeah, there was a 9 up there. So here is your comma sign. I'm going to do this. 5x minus 5x is gone. 9 is the top fraction. I'm going to keep change flip that purple fraction that's on the bottom. So I'm going to multiply by x over 9. Oh my God, the 9's cancel. You have x left over. You're done. You did it. You got 2 x's for your answer, which means, yes, they are inverses. If that confused you, go ahead and watch it again, or go to try this on your homework, on homework number 5, and see if you can get the right answer. Please complete your review packet. Your test is on Tuesday, May 28th. Seniors, you are not taking the test, so please work on your final exam review packet. Have a fantastic rest of your day.